Okay, so let's start now. Today we will be doing progressive waves. If you have any questions from the previous lecture or anything, please let me know. Okay, very nice. So waves are basically, oh no, I had to put it there as well. I'm sorry, wait a second please. Yes. Okay. All right. So waves basically is waves can be defined as disturbance that carries energy. Okay. So waves are of two types, generally speaking. Oh no. So waves are basically two types. One type is electromagnetic, where electromagnetic wave can be like they're all transverse. They can travel in vacuum. In all mediums and vacuum. Some of the examples of electromagnetic waves are like light, X-ray, gamma, etc. And they all have 3.0 times 10 raised to 8 meters per second speed in air or vacuum. So that's their qualities. If you compare that with the mechanical waves, mechanical waves would be one, that they can be transverse or longitudinal. Then they require a medium, so they cannot travel in vacuum. And third, some of the examples are like water, seismic, sound, etc. Okay, like that. Please write this down. Let me know if you have a question. Now, speaking of the transverse wave, then transverse wave is defined as waves that transfer energy perpendicular, let me write it here, sorry, perpendicular to wave oscillation. So what it means is, for some examples are like water, light, seismic, S waves. S waves are basically secondary waves. Seismic means waves that are generated because of an earthquake. If you don't know, that is. Then, like, basically they are generated when oscillations are up and down, and energy, yes, and energy is like going perpendicular to it. Okay. I intended to write it here, but chalo, never mind. Okay. Very well. Very well. Right. Now, then we're gonna go towards longitudinal waves. Longitudinal waves are waves that transfer energy parallel to the wave oscillation. So they could be like sound, they can be made on slinky spring, and they're also seismic primary waves. Okay. So what it means is they vibrate like this, and the energy is also transferred parallel to them like this. So like just like that. Yeah, please write this down. Okay, perfect. Now, speaking of this, then we're gonna look at the graphical representation. So wave can be divided into, like, it can be represented in two ways. Like, you can draw displacement distance or displacement time. The top of the wave is a crest. The bottom is the trough and trough. Okay. Same goes here. Crest, trough, and trough. Now, if you want to find the wavelength, you can do it with the displacement distance wave, because wavelength is defined as distance between 2 points in phase. We're going to talk about in phase a bit later on. The symbol we're going to use for wavelength is lambda, and the SI units are meters, and this is a scalar quantity. So what you can do is you can always go from like crest to crest, find the lambda, or trough to trough. That would also be the lambda. Or you can just go from one whole crest to one whole trough like this, and that is also lambda. So they're same distances. Then once you have lambda, you can then also find amplitude. Amplitude is the maximum displacement of a wave. Okay. Now, The symbol we're going to use for amplitude is A. The SI units, because this is displacement, it has to be meters, but it is a vector quantity. So when you take displacement, you go from mean position. So when I say mean position, it basically means this line, equilibrium. So either you can go like from mean to the crest, that would be amplitude, or from mean to the trough, that would also be amplitude, like this. So you can find it from both ways, it's up to you. Then you can find displacement of crest and trough, or displacement time. So when you have time on this side, you can actually find time period. Time period is basically the time taken to produce one complete wave. The symbol we use for time period is capital T. SI units are seconds, and it is a scalar quantity because just time. So that you can do on the displacement time graph, which means you can go from crest to crest like this, that would be time period. You can go from trough to trough, that would be time period. And you can also go from one whole crest to one whole trough like this, and that would be time period as well. Please let me know if you have any questions here. Okay. All right, now then we have displacement and frequency. Displacement and amplitude has just a small difference, okay? So displacement can be defined as distance specified in a particular direction. Well, let's write distance in a specific direction from its mean position. So the symbol, generally he is going to use X or Y, and SI units the same, meters and vector quantity. So it can be anything, like it can be maybe this distance, it could be this distance, it could be this distance, it could be anything really. And then you got frequency, which is basically number of waves produced in 1 second. So frequency symbol is F. SI units are second inverse or 1/1 second or hertz. That's the same thing, h small z, and it is a scalar quantity as well. The connection of frequency, like frequency can be found using this formula, which is frequency equals to 1/time period. So do remember that. Okay. I hope you guys understand this. Now, these were the most of the definitions required in this chapter. And then we quickly go and find wave speed. So the basic derivation is that speed is equal to distance over time. So speed of a wave, when we're talking about a wave, then you guys should understand that wave speed can be taken as v, distance of one complete wave is lambda, and the time period for that is time period. Since frequency is 1 upon time period, so we can replace it here. That would mean v is equal to f lambda. So that's a small derivation, and you should know. SI units of wave speed are the same, meters per second, and it is a scalar quantity. Okay. Just remember that one, right?
Yes, can we just write it?
It can be done what?
Write this down, please.
You want me to go down?
No, I'm saying, can we just write this down in the notes?
I didn't understand, Ahmad, what you're saying.
I'm saying, can we just write this down in the notes very quick?
Yes, obviously, you should write it. Okay. Now, should we go forward? Ayan, you're done? Ahmad?
Yes, I am.
Okay. So, one of the things is that they're going to ask you about pressure and time graph of a longitudinal wave, okay? So I just want to draw that, and then we're going to do this question. So when you look at a longitudinal wave has like regions of like no pressure, like very less pressure, negative, and regions of very high pressure as well. Dude, this sucks. Like this, okay? 1 2 1 2. Let me make more. Okay, so when you basically draw a graph that represents pressure on this side and time on this side, or distance, whatever that is, doesn't really matter. Let's take distance. So then you should understand that where these points are called compressions, and like this whole part, and this whole part is called rarefactions. So I'm gonna call this C, I'm gonna call this R, C, R, C, like this. So at the middle of compression, you have the highest pressure, like this. At the middle of rarefaction, you have the lowest pressure, like this. And then same goes high, low, high, low, and high. So your wave is going to form like this. Okay. So what we should understand is that here at compressions and rarefactions, we have like, although like from a compression, let me take a different color. Okay, from a compression to another compression, this is like one whole lambda or time period. But also it can be represented as, you know, the highest point and lowest point in the middle as well. Now, this question, it says that the sound wave has a frequency of 2500 hertz and the speed of this. What is the shortest distance from the point of maximum pressure in wave to the point in minimum pressure? So basically what they're asking about is, they're asking about the distance between compression center to rarefaction center, which is basically equivalent to half lambda. Do you guys understand this? Now you should remember this. Now we're going to use V equals to F lambda to find lambda. So lambda will be equal to 1500 divided by 2500. And I'm going to use the calculator here quickly. 1500 divided by 2500, it's 0.6 meters, which means half lambda will then be 0.3 meters, which means the answer has to be B. Everybody understands this? Let me know.
Yes, sir. Yes.
Okay. So most of the people are confused that rarefaction has zero pressure. It does not have zero pressure, it has negative pressure. So please do remember that, do not forget that. Okay, then I'm going to go forward. If you've drawn this, then I would like to go forward, please. Okay, so then, like I said, we basically said that a wavelength is determined when two points are in phase. So what does phase and phase difference mean? We're going to do that. So you guys need to remember, one oscillation means, like if you draw a circle, like when you go in a circle, so you reach from point A and you come back to point A, so basically you have moved 360 degrees, so which means one whole oscillation is 360 degrees. That means a wave is also an oscillation. So at 0 it will be 0 degrees, at 9, like half quarter, it's going to be 90 degrees, next quarter it is going to be 180 degrees, next quarter it is going to be 270 degrees, right? And the next quarter it is going to be 360 degrees. So basically just like a circle, it has 4 quarters and each quarter has a different degree, right? Like, so a quarter would mean 90 because 360 quarter is 90, and you can find any angle in between, like all the angles will be there, so every point will get the chance to have a certain angle. So we can actually compare this with other descriptions, or you know, how we display waves. Like for example, if you have a wave like this and you have a wave like this, let me change the color just to differentiate them. Oh no, this is bad color. Like this, and then we have another wave like this. Okay, so basically we can say that 0 degrees and then 90 degrees and then it's like 180 and then 270 and 360 and then what you got, 450 and then 530 and so on, right?
Can you scroll up?
No, I think I made a mistake, right? It should be 540. All right, like this. Yes. Scroll up. Okay. So when you make a wave, because it's like a 1.5 wave, as you can see, then other waves basically perform the same thing with respect to wavelength and time period, because when in angles the wave is completed, then in meters it is also completed, in time it is also completed. So that would mean that it would be like 0 means just 0 in this one. This distance will be a quarter of lambda, because this is distance. This is like half lambda, which is 180 degrees. Then it is 3/4 lambda. Then it is like 4/4 lambda, or 1 lambda, you can say, right? And then it's like another quarter would be I don't know what. So 1 plus 1/4 is 5/4. I don't know. I gotta check. 1 plus 1/4, right? It's gonna be 5/4. And then 1 plus half. 1 plus half lambda, that's 3/2. So it keeps on going like this, right? Let me write it as 1 lambda. And then for the time period it would be the same, like you can say 0, then a quarter time period, and then half time period, and then 3/4 time period, and then 1 whole time period, and then 5/4 time period, and keeps on going like that, right? 3/2 time period. So we can come to a conclusion that we can say that these points are like, all of this is happening together. So at this point, like if you want to really find all these, so we can say that 360 degrees is equivalent to 1 whole lambda, and it is equivalent to 1 whole time period. So this is the sort of connection between these, and we can always remember this and find phase and phase difference, which will be a big part of this chapter. Okay, if you guys have any questions here, please let me know. Aman, Maham, and Khatija, Irfan, and Dark Legend, and Ayan, Hamad, and where is Sultanat? Okay. Okay. Now, okay, then we are going to go to the next part and see what is phase difference. So phase basically means the position of the point. So for example, it says find the phase of these points. Like if you see, A will be at 0 degrees, and B is 90 degrees, C is 180 degree, D is like 270 degree, and E is like 360, F is 450, and G is 540, and H is 360, and I is 720. So we got like all these phase. Phase means the position of these points at this on this wave, and then we can basically find the phase difference. So let's suppose they say find the phase difference between B and H. So B was like at 90, H was like B and F was like 450. So we can say the difference really is 450 minus 90. So that would be the phase difference. and that would be 360 degrees. If you have a phase difference of this sort, we call this as in phase, and in phase is like 0 degrees, 360 degrees, 720 degrees, and the multiples like this. Okay, now what are the qualities of being in phase? So if something is in phase, we should remember that should mean the particles will have same direction, they will have same speed, and they will have same displacement. Like if you look at this, like B and F on the actual diagram, you might realize that they have the same displacement, both of them. They're gonna go down now, so they have the same movement direction, and they will have the same speed, which is 0 right now. So that would mean that these points are moving together, up or down. So that would mean, or backward or forward. So basically that means that these 2 points are in phase. Okay. Then they've said find the phase difference between F and H. So F is like 450, H is 360, 630. So I'm going to write 630 minus 450. So the phase difference between these two are like 180 degree. So that would mean these are anti-phase, and anti-phase means 180 degree or 540 and then 900. So all these degrees, right, multiples of this would give you anti-phase. Now what is anti-phase? You guys need to remember they will always have opposite direction. They are going to have opposite speed, no, opposite velocity. Okay, speed would be same, just the direction changes, and they will have opposite displacement as well. Okay, so opposite displacement would mean that if you check out this, sorry, we were checking F and H. So F is going down right now, H is going up. It has negative displacement, that has a positive displacement, and they have like the same value of velocity, but same value of speed, but the direction is different, so velocity is different. So you guys need to remember. So if you notice, all of these have one thing very common, and that is all of these have, like, in phase means totally same and anti-phase means totally opposite. Then we're going to check what is D and E. So if you check D and E, here the phase difference is D is at 270, E is 360. So 360 minus 270 would give you 90 degrees. Now this is called out of phase. Now out of phase generally means that everything will be different. It won't be like the same or opposite. So they might have the same or different direction. So you can only tell by looking at the diagram. And then they have different velocity. So I'm not saying opposite velocity, I'm saying different, because the value of velocity and obviously the direction might differ, or it could be same. And then the third thing is that they have different displacement as well. So everything different, not same, not opposite. So you got to remember that. So this would be any other angle. Any other angle then 180 or 0 or 360. So any other angle. So if you check D and E on the graph, so D is like here, so D is going to go up. E will go down, but they have like different displacement. One is at 0, one is at negative, and their value of velocity is also different as well. So this would be how you would basically view the phase and their differences, and you got to remember that as well. Please let me know if you have a question here. Okay.
Sir, the angle of the diameter is it now be 180. If it's out of phase.
In out of phase, it won't be, yeah, it could be 80, 70, 45, whatever. Other than 180 and 0 or 360. Okay. You get it, so Mr. Soel?
Yes.
Okay. So then we are gonna go to the questions and see what type of questions will be there. So in the first question, it says a progressive radio wave in vacuum has a frequency. They've already given this. What is the phase difference between 2 points that are 50 centimeter apart from each other? Now we need to realize this, that he wants angle, but he has given like frequency and distance stuff, right? And this is a radio wave, so automatically we should understand that the speed has to be, it's an electromagnetic wave, speed has to be this. So we can find v is equal to f lambda. We'll find the lambda first. And speed is like 3.0 times 10 raised to the 8. Frequency is 75 times 10 raised to the 6. Mega is 6, by the way, if you don't know it yet. And lambda, we can find. So it's going to be 3 into 10 raised to power 8 divided by 75 into 10 raised to power 6. So it's going to be 4 centimeter, right? Now, what I want to tell you is that actually, 4 meters. 4 meters would basically mean 400 centimeters. So what I'm saying is, what we learned previously was 360 degree was equivalent to a lambda, which means right now for this question 360 degree is equivalent to 400 centimeters. Now if I want to find what is the angle till 50, so I'm going to put 50 on this side and I'm going to put x on this side and I'm going to cross multiply. So it's going to be x will be equal to 360 degrees times 50 divided by 400. So just make a ratio like this. And then it's going to be 360 times 50 and divided by 400, which is just 45, and that should be your answer. Understood? Let me know if you have a doubt in this. Okay. So this is the basic method of doing this, and obviously if you keep on, if you remember this relationship, you will never get it wrong. Anyway, the next question is a difficult question, and I'm going to do this myself and then you guys can do the questions ahead. So it says a transverse wave of wavelength lambda is set up on stretch spring. The graph shows the variation of displacement y with distance x at a particular instant of time. Displacement where x is this is y1. So they have given this. What are the two values x where the displacement y is again equal to y1? So we should understand that we are looking at this displacement. Displacement is a vector quantity. So it means we are looking at this value. We're going to go straight. So we are looking at this and we're going to look at this. Okay. So it is from 0, this distance is like lambda by 8. So from this point it will be lambda by 2 minus lambda by 8. And according to my calculator, then 1 divided by 2 minus 1 divided by 8 is 3 by 8. So that's 3 by 8 lambda. So 3 by 8 means either this or this is correct. These two are absolutely wrong. And then I'm going to check this. So it is like this much distance, which means this point is going to be lambda plus lambda by 8. So 1 plus 1 by 8 on my calculator is 9 by 8, which is this answer. So it has to be B. Well, it was quite easy. But I just want to tell you. Okay, yes. Yes, who was next?
Number 8 is that basically the entire distance from lambda 8 between lambda by 2 and lambda by 8 from y1 to that. So that's not going to be just a small group that you made the arrow between.
You're talking about this section?
No, like the small arrow between lambda by 2 and the purple straight line that you've
This.
made.
Yeah, this
How
what?
is that 3 lambda by 8? It's between the
Yeah, I'm going to explain this. So we're looking at this distance. Basically, it says this is displacement y. We want to know when next time they have the same displacement. So it will be next time here and next time here. Okay, Sultanat, you agree at least to this? So I want to find, first of all, I should know what exactly is this distance. So how do I find this? I have to do lambda by 8 minus 0. So it will be lambda by 8, no? So we only want this distance. Is it clear, Khatija?
Yes.
So if I want to find this point. So it means this is a larger value. It means at this point I got to do lambda by 2 and this point is x, right? So basically lambda by 2 minus x should be equal to this distance. Do you agree? Right? So what did I
So
do?
what was Ben's portion?
Sorry?
Ben's portion between x and lambda by 8.
X and lambda by 8. Yeah, x is this point. Let's suppose x is this point, right?
Oh, right.
So if I want to basically find x, basically this minus x should give me lambda by 8. Do you understand? Like this, what I'm saying.
Yeah.
So instead of making this complicated, what I did was I understood from it that I need to go back by lambda by 8. So if I subtract lambda by 8 by this value, I'm going to get a value on this side. Do you understand? So I subtracted it, I got 3 by 8. Is it clear?
Yes.
Similarly here, the next displacement, I need to go forward by lambda by 8. So going forward means that I have to add lambda with lambda by 8 to find this value because it's ahead that, right? So when I did that, I got 9 by 8, which is this value. So all these values are wrong there. Got it? Okay, should I go forward now? Now this chapter, because this is like a bit, although we'll solve further and we'll see how it basically makes a huge difference. So when you're making many waves together, which are like you going, so wavefronts is a perpendicular. Wavefront is a perpendicular line to direction of wave that connects the crests going together in phase. Okay, which means that, or going together, just write going together, that would be easy. So these are the crests, as you can see. So it means that if I draw a line like this, a straight line basically, so that would be a wavefront, this would be a wavefront, this would be a wavefront. So I'm just connecting the crest. So all these are wavefronts, and the direction of wave would be like this. So that would be the direction of wave, which basically means that now why I have written its perpendicular line, because with the direction it is going to be 90 degrees always. Remember this. The good part about wavefront is that between two wavefronts, like from one to the next one, successive one, you can find lambda or time period, whatever you want to find. Okay, so that's one property that you guys should remember. Then, so when you generate wave, obviously it carries energy, and wherever it is going, the energy is basically, it has to be delivered at some point, right? And while it's being delivered, it will have some intensity. Now, intensity has a very simple definition. Intensity is power transmitted per unit area, and intensity symbol is basically I. SI units of intensity are watts per meter square. Okay, so generally intensity formula is written as power over area, like this, and where I just want to quickly write that this is your power, this is area, and this is intensity. Okay, further you can also write it as intensity. Power itself is energy over time, so you can write energy over time over area. So that would be also intensity, just to tell you that. Okay, so I'm just gonna write this is energy and this is time as well. If you want to use this formula, that's also okay. It depends on the question that they've asked. So when you're looking at, intensity, you should understand that intensity depends on three different things. It depends on amplitude, it depends on frequency, it depends on distance from the source, okay? And with amplitude, intensity is proportional to square of it. For frequency, intensity is proportional to frequency, and intensity is inversely proportional to distance square. So you got to remember that, right? For example, suppose in a amplitude question says that intensity of a wave with amplitude A was I, then what would be the intensity if the amplitude was 2A? So you already know that it's a function of square, so you can write it as 4 times the previous intensity, like that. Okay, now to make things very simple, I would like to give you a formula that you should remember, and in any case this formula will help you a lot. So you can write intensity of the first wave divided by intensity of the second wave will be equal to amplitude square of the first wave over amplitude square of the second wave. Will you guys be able to remember this?
Yes.
Okay, then for the frequency it is the same thing. So let's suppose they say there was a intensity I when the frequency was f. When frequency became 2f, then intensity would be 4 times the intensity, keeping in mind the other things are constant. Then you can actually put another formula to use, which is like I1 intensity of the first wave over intensity of the second wave equals to frequency of the first wave squared and frequency of the second wave squared. That would give you the relationship between frequency and intensity as well. And then with the the distance, because distance, if you say at x the intensity was I, so what would be the intensity when it was 2x? So it would be basically a quarter of I, because it is inverse square. That would mean 2x means that it's going to be 1 upon 2, and when you square it, it will be 1 upon 4. Alright, you got to remember that. For this, the formula changes a bit, like intensity I1 over I2, first wave or second wave, equals to distance of the second wave square over distance of the first wave square. Because these are inverse ratio, that's why now like there's x2 on top and x1 at bottom. Otherwise the relationships are just like this. Is it clear, everyone?
Yes.
Okay, please write this down so we can then go and check some questions out. Okay, now it's working, which is good. Okay, so now I'm gonna go to the next part, which is this question. Now in this question, which looks complex, but it's not complex at all. Just see that it says wave x has a frequency f and amplitude a. What is the frequency? What is the amplitude of y? Okay. So, well, I don't think that this is like related to intensity at all. I thought it was related to intensity. So, I'll do it anyway. So, if you see within this, like the amplitude is like x has, let's suppose a, then it's like 1 and this is 2. So, amplitude would be 2a. So 2a or 2a, that would be wrong at all. And for frequency, basically x is like one wave happens like when half of y has happened. So it means the frequency of y should be half of the first one. So that's pretty simple. That has to be b. No biggie. And I never intended to put this question anyway. Lekin chalo koi baat nahi. We're gonna go forward. Okay. Then we're gonna go towards the next question, which is the question I'm gonna do. Yeah, this is the question. Okay. So in this sort of question, it says the intensity of wave x is I, as you can see, whatever the wave x is, and then use the figure to determine the frequency of this. So that's pretty simple. You can see this is the crest, this is the crest. So from here till here, that would be the time period. And we know this is 0 and this is 4. So its time period is 4.0 milliseconds. Please do not forget the units here, because a lot of people do. And that's 10 raised to minus 3. And if I want to find the frequency, use the calculator. 1 divided by 4 divided by 10 raised to minus 3. So that's going to be 250 is the frequency, okay? I'm going to write 250 hertz. Then says a second wave of same frequency also passes point P. The wave Z has an intensity of 2I, okay? And the phase difference between two waves is 90 degrees as well. So we need to remember that they're out of phase by this. And they say sketch the variation of wave of displacement Y on wave Z, show your working. So first of all, we need to fix what is intensity, what is happening to intensity. To make the wave on the diagram, I need to have the amplitude, right? So I'm going to use the equation I1 over I2 equals to A1 squared over A2 squared, like this. The first wave has an intensity I, right? And the second wave has intensity 2I, like it says. The first wave has an amplitude of 2 centimeter. So I'm going to write here, I'm going to write 2 whole square, and I want to find the amplitude of the second wave like this. So I and I will cancel out. So you always use this formula. And A2 square will be equal to 2 times 2 square. So that's going to be like under root, and then A2 will be equal to 4 and 2, 8 under root. And that will be under root 8. Under root 8 is going to be 2.23 or 2.8. Yes. Yes. Yes, sir.
And second equation where you wrote 2 square, then why did you multiply 2 by 2?
Because so here this goes here, this goes here.
Okay.
So I and I will cancel out, right? It will become half
So you
equals
didn't
to
cancel the 2 from I.
4 over A square. Where did I not cancel that?
Okay, so yes, I get it.
Okay. Now you get 2.83, which means this is the amplitude. But now we also need to know what is the phase difference. Phase difference would mean that the time period, like we know the time period was 4 milliseconds. So that is equivalent to 360 degrees, because we know one time period is 360. Then what will be the time period difference in 90 degrees? So I'm going to cross multiply this. And it's going to be 90 times 4 divided by 360. So that's going to be 90 times 4 divided by 360. So that would be 1 millisecond phase difference. Now please check this out. So what I need to do is I need to make a wave of amplitude 2.83 meters or centimeters, sorry, and 1 milliseconds ahead from the wave that is shown. Okay, that's what I need to do. So I'm gonna go and do this. First of all, on this diagram, I'm gonna find where the 2.8 is. So this is like 2.2468. So it will be somewhere here. Yes.
Everyone's 1 millisecond ahead and not behind.
It's the same thing like behind or ahead. There has to be a difference, it says. Okay.
Okay.
So we can't go behind because we're starting from this point. So we're just gonna go ahead. Okay. But that's alright. So what you're gonna do is you need an amplitude 2.8. So I'm gonna go here. So this is my amplitude, and at the bottom as well, this would be my amplitude right here. Okay. Now, so every point will be shifted 1 millisecond ahead of this wave, which means that 1 millisecond is this much, right? This is 1 millisecond. So it means this point, like the amplitude will come here. So this point shifts to here, and this point shifts here. So I'm gonna keep on making this. This point shifts 1 millisecond ahead. This point shifts. अच्छा मैं कर लूँगा जी. Okay, then this and this will be here, and this will be like the same point. Oh, this point here. So now you start making a wave. Okay, I'm gonna make a wave like this and this and this. Now obviously this will just go down like this. All right, so now what you're gonna see is that every point on the new wave, which is Z, has a new amplitude of 2.8, and it is like every point is shifted to like 1 millisecond ahead. That is why, because we need to understand that that's the phase difference between them. Do you guys understand now? So this is a difficult question, just I wanted to make sure that you guys understand this completely. Okay, yes. Khatija's and Sultanat and Dark Legend and Ayan, Maham and Laiba, Javeria. Okay, Hamad,
Yes,
Maham. Okay, very good.
Yes, sir.
Now, this question is the same question, okay? Just the same question. They have just made the wave themselves, and you want to find the phase difference. So I'm just going to leave this to you, and I'm going to say, okay, you guys are fully capable of doing this. So please do this as homework, and if you still don't do it by tomorrow, I mean the next week, whenever we're meeting, then you can ask me and I'll help you with this. Next, all these questions I'm going to give you as homework because these are just practice ones. And I know you guys will be able to do it. All these. And every chapter when I put them, the more the questions I put, it means that is like the most recurring chapter that you need to do. Okay, so make sure that you keep on doing this. And I skipped so many questions already because they were extremely similar, but you still need to do it. Anyway, so question number 5 is the parallel light rays, and this is sort of a question that came, I think, very recently, like May, June 2022. So it says that parallel light rays from sun are incident normally on a magnifying glass. The magnifying glass directs the light onto area A. This is the magnifying glass, and it is redirecting to small area A. Okay, so the light is coming from the sun, and which has a radius r, as you can see. Now it says that calculate the power of light from the sun incident on magnifying glass. So we should already remember that intensity is given by power over area. Now area is this much, right? This is the area, obviously, and it's like, I don't know if it's circular or whatever. It's a circular cross section, okay, and radius is this one. So area would be written as pi r square. You guys know this already. So intensity was 1.3 times 10 raised to 3, because this is in kilowatts, and then it was like power divided by pi, and the radius was 5.5. So I'm going to change this into 10 raised to minus 2 for converting into SI units. So power then will be equal to, when this whole thing gets multiplied there, so 1.3 times 10 raised to power 3 multiplied by pi multiplied by 5.5 times 10 raised to minus 2 whole square. So that would be 12.4 watt. Now I just, you see, because again I'm just going to tell you, because my answer must be in 2 or 3 significant figures, as my data is 2 significant figures. So I can take like the same number of significant figures or one more than that. Please don't write 12.35. 12.35 would be wrong, and writing, I think 10 would also be wrong if you convert that. Okay. Same rule goes for paper one. Yeah, you have to do that in paper one as well, and the practical paper as well. Is it clear?
So writing 12.35 will be wrong.
Yes, they will cut 1 mark. So please don't do that. Anyway, now it says calculate the intensity of the light on area A, and radius is 1.5. So we already know that intensity and distance has a inverse ratio. So can somebody please remind me what was that ratio that I told you? I1 over I2 with respect to distance, please.
x2 square over x.
Yes. So intensity in the first one was 12 watts, like 12 divided by, I want to find I2. The initial radius was 5.5 whole square, and the final one was 1.5 whole square, because it's, sorry, what? No, 1.5. Yes, it's given here. So I'm gonna basically find this. So it will be 12 times 1.5 whole square divided by 5.5 whole square equals to I2. And let's do this. And if you just remember these formulas, right, you're never gonna get anything wrong, and obviously you'll be quite happy when you come out of your exam. What? This is not fair. Did I misstep this? It needs to be, oh, I wrote everything wrong. Sorry, it should be 1.5 and 5. Yes, I switched. I should have switched. Sorry, 5.5, 1.5. So I think I'll write 5.5 here. What is this? Okay, never mind. It doesn't let me write. And 1.5. That's 161. 161 watt per meter square. Is it clear, everyone? So
Yes, sir.
this would be this simple if you just follow the formulas and nothing bigger. Yes.
Intensity 12 to me.
Because the initial intensity was 12, no? Oh, sorry. I should have taken 12.4. My bad. You guys don't tell me. That's not fair. 12.4. It will be 1667. So it's going to be 167. Like this. Okay. Now it will be fine. Okay, perfect. So I hope you guys understand this. Let me know if you have a question.
It's clear, sir.
Okay. Then
Sir, I have a question.
yes, Sultanat.
Sir, why did you take 12.4 for intensity, where 12.4 is power?
Oh yes. My bad. Well, the answer will be different. I'm sorry, that would have been the power. Sorry, that's not fair. I forgot about it at all. I thought it was intensity.
Plus, sir, I have one more question.
Yes.
That one length is in 1.5 millimeter and the other is 5.5 centimeter.
Are you sure? Okay, yes, you're right. Oh my god, so many mistakes in this. I'm gonna fix everything. Wait, so intensity was 1.3 times 10 raised to power 3, right? That was the intensity. Yes. And the other intensity was I2. The other length was 1.5 times 10 raised to minus 3. And that length should be 5.5 times 10 raised to minus 2 and whole square. Now it will be fine. You are so right. So that would mean we're multiplying. That would give us a very big number, I think. So I'm going to multiply this with 5.5 times 10 raised to minus 2, and I'm going to square this up, and then what do? Divide it by 1.5 times 10 raised to power minus 3, and then square it up. That's pretty good. Oh my goodness, that's a big number. So the number I get now is 1.8, 1.7, in fact 1.7 times 10 raised to power, I think this calculator sucks sometimes. Okay, 1.7 times 1.75 times 10 raised to power 6. Okay, so it should be 1.75 times 10 raised to power 6. Okay, now it is correct. I think so. All right. Okay, that's it. I don't think so I've made any other mistake, right? Can you see? They just give this for 1 mark. This is not fair. Not fair at all. Chalo, no worries. Anyway, so we're gonna go to Doppler's effect then. Doppler's effect will also be a considerable, like it will have considerable amount of questions. And Doppler's effect is basically the apparent change in frequency. Okay, apparent change in frequency observed by a stationary observer when the source is moving relative to the observer. So there is some keywords that you guys need to write. First keyword is it is the apparent change, and then stationary observer, and then relative to the observer. So you got to write this. Then I just want to tell you that these have just one formula, which is F naught equals to Fs times V, Fs times V, V plus minus V plus minus Vs. This formula is already given. This is already in your like formula page. Okay, so you don't need to remember this formula, but you need to know what this plus minus sign is and what the values are. So F naught is the observed frequency, Fs is the frequency of source, that was the original one, and then V is the speed of wave. It could be sound, it could be light, and Vs is the speed of source. So these are the things you should remember. Now okay, please write this down and then we're gonna move forward. Okay, so what happens is, suppose there is one person standing here, let's call him observer 1, and one person standing here, let's call this observer 2. And this, my friends, right in the middle, that is your source. Okay, so the source is currently has no speed, the speed in this 0, so the wavelength that is observed by this observer and the wavelength observed by this observer is the same. Okay, but when the source basically starts moving, like now it has a speed vs, right? So what happens is, as you can see, that the observer in the front of this, towards which the source is moving, is going to observe a smaller wavelength, which means smaller wavelength would mean higher frequency, and observer which is standing behind is going to observe a larger wavelength, which means a smaller frequency. Is it clear, everyone? So that's just a apparent change that happens. Now, very simple, I just want to tell you, for this person, let me just box him. Okay, so this person, when source is moving away, so all you need to do is you need to use this formula, F naught equals to Fs times V over V plus Vs. So you got to add the velocity here. Okay, and for this person, which is like when source is moving towards the observer, then you got to use F naught equals to Fs times V minus Vs. Is it clear, everyone?
Yes, sir.
That's basically all you need to know. Sorry, come again? So basically that's all you need to know. That's nothing else in this particular thing, right? No. So we got, yes, Sultanat, you're telling something to me? Okay. So first thing, that is a clear question of this. It says, which type of waves can Doppler shift be observed? So Doppler shift can be observed in basically can you do it in water waves? Yes, you can do it in water waves as well. So all types of waves can be, they can show Doppler shift. Is it clear, everyone? Okay, so waves basically all waves behave the same, so we don't have to worry about that. Then in the next question, which is basically the star one, which states that a distant star is receding. Receding is a word that we use when we have to say it's moving away. Okay. Okay, so it's moving away, and it says the Doppler formula can be used for this. So it says the speed from Earth, like relative to Earth, is this, and emits light of frequency, and the speed is this. So it says use this. So if it is moving away, which formula should I use? Can somebody please tell me that? Yes, F equals to Fs times V over V plus Vs. So just put in the values, like the frequency is 5.7, that's the source frequency. The speed of light is this one. Yes, Laila? Sohail, I cannot hear, your voice is breaking completely. No, it's not. I can't understand what you're saying. Okay, like this. So then you just simply put in the formula, which is 4.57 times 10 raised to power 14 times 3 into 10 raised to power 8, and then 3.0 times 10 raised to power 8, and then plus 1.4 times 10 raised to power 7. So So that's gonna be, oh my goodness, that's gonna be 4.4 times 14. 37 times 14. So that's gonna be your answer. Pretty easy, simple, that's not a big deal. So I'm gonna give you this as homework. The next question is super easy, you can do it on your own. And then I'm gonna go to this question. So this question is like something new. So this is for homework because I already told you the definition, but we're gonna do this one. So it says a child sits on a rotating horizontal platform on a playground and there is a observer right here, okay? The child moves in a constant speed in a circular path, as you can see, and says the observer is standing long distance away. During one particular revolution, the child is moving at a 7.5 meters per second speed and blowing a whistle and stops blowing at Q. So he keeps on blowing the whistle till he reaches this point, okay? So it's gonna go like this. And then it says the whistle emits a sound of this. So this is basically Fs and this is V, and it says determine the maximum frequency. So maximum frequency would be when it is moving towards the observer, the child is like moving towards or away from the observer. What do you guys say?
First,
So what point that might be? P or Q or maybe R? What do you guys say?
sir, I don't get it. P.
No, it says if you're moving like if you're going like towards, the frequency is greater, and when you're moving away, it is frequency is lesser. Okay, Laiba? So that means at this point, this person will observe the maximum frequency. Do you understand? At this point. And he will observe the minimum frequency at this point. Is it clear? Because if you're going away, then the frequency decreases. Okay, Laiba?
Yeah.
Now, I just want to determine that, and that would be when you're moving towards something, then you use F equals to F naught equals to Fs times V, V minus Vs or plus Vs. What do you guys say?
V minus Vs.
Minus Vs because it's moving towards, right? So the frequency of the source, we don't know, right? We know. So 950 times 330 divided by 330 minus 7.5. So that's going to be 950 times 330 divided by 330 minus 7.5, and that's going to be 972. So I'm going to write 972 hertz. That's simple. Okay. Now it says describe the variation of frequency of sound heard. So basically from P it will be maximum, at Q it will be minimum because it's moving away. So for 2 marks we're going to say max frequency heard at P because child moving towards observer. All right, then frequency decreases and minimum frequency observed at Q as child now moving away. So this is how you're going to explain this. All right, any questions, please let me know. Good. Now this question and this one is the same one, so you're going to do this now as homework, same question, but I'm going to do this question because this is a different question, and then you can do this one. This is for homework, and obviously this one is also for homework. These are the same type of questions. They've just given you the same thing many times, so obviously if you practice them enough. What is this? Oscilloscope. Oh, you don't have to do oscilloscope, please. That we're going to do in the next class. Anyway, so I'm going to do the last question today, and then we're going to call it off. So This is a different type of question where it says there is an initial position of ambulance, there is a final position, and the ambulance moving towards the observer, then away from this. So when it is moving towards the observer, I should use F equals to F naught equals to Fs times V and V plus Vs. Am I right?
Yes, sir.
No, it's a negative. Very bad. And when it is moving away from the observer, it should be F naught equals to Fs times V over V plus Vs. Is it clear? Remember that. Now it says which overall change would take place when it is observed at this point and at this point. You have a frequency of this and speed of this and speed of a sound is this. So for the first one, initial position, I'm going to use F naught equals to 600 times 330 divided by 330 minus 25. Okay, so I'm going to use this. Let's write it down. 600 times 330 divided by 330 minus 25. So I get 649.18, and then for the final position of the ambulance, I'm going to get F naught equals to 600 times 330 divided by 330 plus 25. So only you need to remember this. So then you get 557.7 hertz, and now we need to find the change. So the change in frequency is going to be 649.18 minus 557.7. So I'm going to use that. 649.18 minus 557.7, and that is equivalent to 91.48, which is basically this answer. Is it clear, everyone? Let me know if you have a question here. So these are the only 3 type of questions that they can give you. There's nothing else, and I hope to see you in the next class. Have a nice day. Bye.
Bye, sir.
Bye.
Bye, sir.